Okay, question 17. At time t, particle P leaves the origin O, moves along the x-axis. So there is origin O. There is the said particle moving along the x-axis. X increasing to the right. At time t seconds, the velocity of P is v meters per second, where v equals that. So we've got, you can see, we've got the velocity is equal to 6t minus 2t squared. What's the 2 off there? 2t squared. Find the maximum value of v. Okay, so again, if this was just a graph, maximum value of v is where the acceleration equals 0, or if it was a graph, as you can imagine, differentiate with respect to t, and you can see that's acceleration anyway. So you're after a shape of graph because it's a smart, an unhappy face, quadratic. It's going like that. We're after this stationary point here, also where acceleration equals 0. So here we go. We're going to diff. This is part A. Diff with respect to t, and we end up with dv by dt, which is acceleration, is equal to 6 minus 4t. Okay, at dv by dt equals 0, where acceleration equals 0, or the stationary point, we've got 6 minus 4t is equal to 0. Therefore, t equals 6 comes over, that comes over, divide by that, and you end up with 3 over 2, 1.5. Okay, so 1.5 seconds it occurs at. Right, now we've got to find the maximum value of v, so now you've got to shove that back into here. So therefore, v is equal to 6 lots of 1.5 minus 2 lots of 1.5 squared. Okay, so calculator out, and there it is. So I've got 6, in fact, delete brackets, 6 times 1.5, close brackets, minus, open brackets, 2 times 1.5 squared, close brackets, equals. So v, maximum v is 4.5 meters per second, and that's the answer that they want. Now part B says the time taken for P to return back to O. Okay, so the time taken for it to get back to O. So part B, we've got part B, what it's doing is, this is coming back out, and it's going to hit a stationary point at 1.5 seconds, and then as t grows, it's going to go back on itself, back to here. Okay, so we're after a place where the displacement is 0, so we need displacement. So now we're going to get the velocity and integrate it, because we know that velocity is equal to dx by dt, which is equal to 6t minus 2t squared. So we're going to integrate both sides with respect to t. Okay, so dt is equal to integrate 6t minus 2t squared with respect to t. So you get back to x, which is the displacement. You end up with 6t squared over 2, which is 3t squared, minus 2t cubed over 3, so 2t cubed over 3 plus c. Now, right back up here, we're told that at time t equals 0, it leaves the origin, so we know the displacement. So at, very good, at t equals 0, we've got x is equal to 0. So we've got, therefore, 0 is equal to c. So, therefore, we end up with x equals 3t squared minus 2t cubed over 3, and we want to say where's the displacement going to be at the back to to the origin, so the time taken to get back to the origin. So at x equals 0. So we're going to solve 0 equals 3t squared minus 2t cubed over 3. So pulling out a t squared, so you got 0 equals t squared, you're left with 3 minus 2t over 3. Obviously t equals 0 is one solution, it's not what we want, and the other solution is going to be this one here. Throw that over, times by 3 and divide by 2, so therefore the time equals 4.5 seconds. Okay, so that's the time that it takes to return back to 0. All right, so I hope that helps.